All right, now that we studied moments, let's write down what our takeaways are and what we learned so far. Please indicate what is clear to you and what is not clear to you, and more specifically, how you think you can get a better understanding of that. That will really help you and help us to define how to train you better for the upcoming tasks. But once you've done that, let's take a look at the checkpoints actually of today's lecture so that we can agree on what we needed to learn here. First of all, we definitely understand the definition of a moment and that is the tendency to rotate. And the key word here is tendency, because if rotation is allowed, then it would create no moment. So we can check that off. We definitely understand that. Well, we are also aware that moments are always generated by a force times its lever arm, and that both of these, the force and the lever arm, have to act in the same plane to generate a moment that is perpendicular to that force lever arm plane. And today you did not really have to worry about this. I mentioned this to you because we only dealt with XY planes, and therefore the moment was described by clockwise and counterclockwise, and therefore we got away with defining them as scalars and indicating the clockwise or counterclockwise. But in reality, those moments point in the z direction, and that's what we're talking about here, right? So you understand that the force lever arm plane is perpendicular to the actual resultant moment. All right, furthermore, we definitely understand that we need the perpendicular component, and this could be either the perpendicular lever arm or the perpendicular force component. It doesn't really matter, but only the perpendicular component really creates the torque or the moment. Please memorize this. And we also understand that the directional sense of the torque is really ultimately defined by the right-hand rule. I think we talked about this just right here when we talked about the force lever arm plane, because we only dealt with XY and it was always in the Z direction. So that's kind of repeated in here, but specifically for the right-hand rule. So I can check that off as well. Now, the moment, of course, always depends on the lever arm, and therefore it must be described by the reference point or relative to a reference point. Without a reference point, you would not be able to clearly describe or define a moment. And that is also reflected in the next point, where it says that you understand that no moment can be generated if the force passes through the reference point. Because in that sense, you actually have a distance of 0 to the reference point, and therefore the reference point is not really existent, or however you want to look at it. But if that is the case, if your force passes through the reference point, then you do not have a moment or a tendency to rotate, really, and therefore no moment. Furthermore, we understand that a moment system can be generated by multiple moments, and I can sum them up to determine the total resultant moment about a point. That is, of course, only the case if the lever arm and the forces act within the same plane. But for now, this is always the case here in this class because they are always acting in the XY plane. But you understand that if you have F1, F2, F3, and they all rotate about a point, then they can be summed up. So I can check that off as well. Last but not least, of course, we can calculate now, due to the examples that we did, the acting moment. And the key word here is really acting. So I encourage you to think about that. We have not talked about reaction moment yet. We only talked about the acting moment. And we can do that now for simple 2D structures with even multiple forces. That's what our examples were all about. So I can check that off as well. And that concludes our concluding lecture page here. And we are now ready to take a look at the homework. Let's get started on that. As always in our homework, we start from the very simplest case and move up in complexity. But for our very first problem, don't be surprised if it's too simple. There's only one force acting on this L structure here, or an L that lays on its side. And it's a cantilever which has a fixed point at O, and you need to find the moment that is acting at O due to this force. I don't think there's much that I need to explain to you here. Just make sure that you find the right lever arms, the right components, and you're good to go. Let's move on to the next problem, which is where the fun starts. So this looks a little bit more complex, or at least you have to do some geometry analysis here because your force is acting down here on this steel structure, and you need to find the moment acting at O. So I believe it is one force that requires one lever arm, but that one lever arm you of course have to find through geometry. Let's look at our next problem. See, now the structures become real and they start looking like what you would see in real engineering structures. So you have this system here where you have two forces acting on point A, and you need to find the moment at O right here. I don't think there's much I need to tell you. You see it becomes very much repetitive at this point, of course, with different outlooks on the actual problem. So for example, here we describe the forces differently just to get you used to that. And then this is a problem that we initiated in our examples. I believe you have everything you need to solve this properly. You find the moment about this point. So make sure that you break down the forces into proper force components, identify the proper distances, and then multiply it by the directional sense, or add the directional sense correctly, which means positive or negative. Positive for counterclockwise, negative for clockwise. Because it's so much fun, we have one more problem for you on the next page. Let me zoom out here first. So this is the first part of the homework, and we have this last problem here, which I believe is probably the most involved one in this homework set, but ultimately we kind of solved this as well in the lecture, so you should be able to solve this. You just need to find the proper force components and the proper distances to find the moment about point A. That concludes the lecture about moments as scalars. I believe I gave you all the tools that you need to solve your homework effectively, and I wish you good luck with that. I'll see you in the next lecture. Stay safe.